Batch mode active learning. Batch mode active learning is a technique used in stream-based active learning where a set of labeled instances is selected from an unlabeled stream of data for annotation by an oracle. In contrast to other active learning strategies, batch mode active learning allows for the annotation of multiple instances at once, which can expedite the learning process and make it more efficient. The goal of batch mode active learning is to select a batch of instances that will provide the most informative data points for model training. By selecting instances strategically, we can minimize the number of instances that need to be labeled, while maximizing the overall performance of the model. In order to understand batch mode active learning better, let's dive into the steps involved in this process, which include data stream ingestion, feature extraction, model initialization, batch selection, instance annotation, model update, iteration. 1. Data stream ingestion. Firstly, we need to create a data stream from which we will select instances for annotation. The data stream can be any form of data, such as text, images, or numerical data. This stream can be infinite or finite, depending on the use case. 2. Feature extraction. Once the data stream is available, we need to extract relevant features from the instances. Features can be any measurable properties of the instances that can help discriminate between different classes. Common feature extraction techniques include word embedding, image feature extraction, or numerical feature extraction methods. 3. Model initialization. To perform batch mode active learning, we need to initialize a model using the labeled instances. This can be done by selecting a small random sample of instances from the data stream and annotating them. The model can be any supervised learning algorithm, such as decision trees, support vector machines, or neural networks. 4. Batch selection. Once the model has been initialized, we can start selecting batches of instances for annotation. The goal is to select instances that will provide the most valuable information to improve the model's performance. Various strategies can be used for batch selection, such as uncertainty sampling, diversity sampling, or density-based sampling. These strategies aim to select instances that are challenging, representative, or informative for the model training. 5. Instance annotation. After selecting a batch of instances, they need to be annotated by an oracle. The oracle can be a human annotator or a pre-labeled dataset. The annotations can be binary labels, for example, positive or negative, categorical labels, for example, classes, are continuous values. 6. Model update. Once the instances are annotated, the model needs to be updated using the newly labeled instances. The updated model will now have a better understanding of the data and will be able to make more accurate predictions. The update can be done using various techniques depending on the chosen model and learning algorithm. 7. Iteration. The previous steps 4 to 6 are repeated iteratively until a stopping criterion is met. The stopping criterion can be a maximum number of iterations, a fixed budget for annotation, or a convergence criterion. Batch mode active learning offers several benefits over other active learning strategies. Firstly, it allows for the annotation of multiple instances at once, reducing the overall annotation cost and time. Secondly, it enables the exploitation of dependencies and relationships between instances in a batch, leading to improved model performance. Lastly, it facilitates the inclusion of domain knowledge or contextual information when selecting batches of instances. By following the steps outlined above, you can implement batch mode active learning in stream-based active learning scenarios. It is essential to choose the right batch selection strategy and model update technique to achieve the best performance for your specific problem domain.